Hi guys, and welcome back to another past paper workthrough. This one is from the Cambridge International AS and A-level papers. This is from February-March 2022, so earlier this year. Okay, in the video description below there will be a link to the website where you can find all the past papers. So it'll be this website here. You can choose this is for Cambridge, you can choose your ASA or A-levels, your O-levels, or your IGCSE papers. There are also marking schemes and examiners reports and everything you can have a look at here, including the past papers. Okay, so this is paper 1, pure mathematics. And some of the instructions, the most important things here for us is the rounding off. Give non-exact numerical answers correct to 3 significant figures or 1 decimal place if you're using angles in degrees. So if you're doing angles in radians, we also want to do 3 significant figures. Okay, unless a different level of accuracy is specified in the question. Okay, so let's get into it. First question here. So here we have a curve with an equation of fx is such that the derivative, or f prime of x, is 2x to the power negative a third minus x to the power positive a third. It is also given that f of 8 equals 5. Now we need to find the function. So we get given the derivative. So if we have a derivative and we want to find the original function, then we have to integrate, right? Because from the function to the derivative, this is differentiation. So to go the other way around, it's the opposite. We do integration. Okay, so let's integrate. So if we have our, well, let's do this. Let's say our function is going to be equal to the integral of the derivative of the function with respect to x. All right, so that's going to mean we have to integrate this function, which is 2x to the power negative a third minus x to the power positive a third. And all of that we want to integrate with respect to x. Okay, so this, if we want to write it properly, we can also just say, let's split this up into 2x to the power negative a third. So we're going to, negative a third. So we're going to integrate that with respect to x, and then we're going to subtract the derivative of x to the power third with respect to x. Okay, so this first one, if we integrate this, we know our general rule of integration is just 2x, and we add 1 to the exponent. So negative a third plus 1 is 2/3. And then we also divide by the new exponent. So divide by 2/3. And we want to integrate that. We don't have, it's an indefinite integral, so we don't integrate from any specific value to another specific value. We're just going to say that. So that part plus some constant, let's call it small c. I'm going to call it c0, right? Because we want to do another one here. So minus, and then we're going to integrate this part. So add 1 to the exponent. 1 over 3 plus 1 is 4 over 3. And divide by the new exponent. And remember to add our plus constant. So let's call that C1. Okay, so now let's simplify this a little bit. So 2 divided by 2/3 is going to be the same as 2 times 3, which is 6, divided by 2 is 3. So 3x to the power 2 over 3 plus some constant. And then let's do the same here. So divided by 4 over 3 is the same as timesing by 3 over 4. So it's going to be minus 3 over 4 x to the power 4 over 3 minus our constant c1. So these two constants, if we collect these two like terms, that's just going to be some new constant, which we'll call, let's call it k. Okay, so far we have 3x to the power 2/3 minus 3/4 of x to the power 4/3, and then plus some constant, let's call it k. Now to find that constant, we need to substitute a point in, and we've got given a point here. So we have the point where x is 8, then y is going to be 5. So we're going to substitute that point in. So y is 5. Let's just write this down to be sure we got the right thing. So we're going to substitute the point 8, 5 into our equation. Okay, so that means y is 5 when x is 8. So 3 times 8 to the power 2/3 minus 3/4 of 8 to the power 4/3 plus some constant. Okay, so now we can solve for the constant. So this is 5 equals, okay, 8 to the power 2/3 is going to be 4. 4 times 3 is 12. Here we've got 8 to the power 4/3 is going to be 16. Times 3/4 is going to be 12. Okay, that works out quite nicely. So 12 minus 12 is 0, so we just have 5 equals k. Now our final answer, we have to put all of that together. So our function f of x equals, so we've got 3x to the power 2/3 minus 3/4 x to the power 4/3 plus our constant, and our constant is 5. So that is our final answer. Success. Let's just make sure we read everything correctly. Yep, just find f of x. All right. How many marks is that? 4 marks. Nicely done. Second question. So we've got a curve with this equation and a straight line with another equation where c is a constant. Find the set of values of c for which the curve and the line intersect at 2 distinct points. Okay, so basically what we want, so this is a parabola, but it doesn't really matter if we know it's a parabola. So we've got, let's change colors for each question, I think I like that. So we've got some function, so it doesn't matter if it's a parabola or not, but let's say it's parabola because we know this one is, right? So x squared plus ax squared plus bx plus c, that's a parabola. So it looks something like that. And we've got a straight line, 4x plus c. So it's got a gradient of 4, so it's like a steepish kind of line. And now we need to find what is the value of that of c, and same for the c here, so that this intersects at 2 distinct points. So we see here intersects at no points, but if that c moves up, right, c is our y-intercept, so as the graph goes up, then at some point it's going to be a tangent, just touching it, right, because then there's just one point of intersection. And then as we move up, so anything above some value here, then will give us a point where there's 2 distinct intersection points. Okay, so how do we find the points of intersection? The points of intersection are where the graphs are equal to each other, right? So that would be like there and there. How would we find those points? We'll just set this equation equal to that equation. Okay, so let's do that. So we're going to set x squared plus 2cx plus 4 equal to the straight line, so this is a parabola, equal to the straight line 4x plus c. And then we're going to solve it. Well, we're not going to solve it really, but what we can do here is let's take everything across to the left-hand side, because that's usually how we solve a quadratic equation, right? So x squared plus 2cx, and then I'm just going to take the minus 4x, and then plus 4 minus c equals 0. Okay, so let's just group together all our variables. So x squared, that's the only x squared. And then we can factor out an x here, and we're left with 2c minus 4x. And then our constant is just 4 minus c. Okay, so how would we usually solve this? Well, we would usually just plug this into our equation, right? Into our quadratic formula, which is this one. b squared minus 4ac over 2a. Right, that would give us the points of intersection. But now we want the place where there's 2 distinct points of intersection. 2 distinct points. So what can we look at here in order to get 2 distinct points? Well, we basically only have to look at this part here. Because if this b squared minus 4ac, if that is 0, then what happens? Well, then we'll get x equals negative b plus or minus the square root of 0 over 2a. And what is the square root of 0? Square root of 0 is just 0. So we'll have negative b plus or minus 0 over 2a. And plus or minus 0 doesn't change anything. So that'll just be negative b over 2a. So that's just going to be one answer, right? So if this thing equals 0, that is 1 point of intersection. 1 point of intersection. Now, if that thing is negative, so let's say if b squared minus 4ac, if that's negative, what happens then? Well, then we've got x equals negative b plus or minus the square root of something negative here over 2a. And what happens then? Well, negative b plus or minus, what is the square root of a negative number? Well, it's non-real. This is some non-real number over 2a. So this is no real solutions. That'll be no points of intersection, right? So this gives us no points of intersection. No points of intersection. Okay, so the other option, if that's bigger than 0, so if b squared minus 4ac is bigger than 0, then what happens? We've got negative b plus or minus the square root of some positive value over 2a. So that'll give us x equals negative b plus something. But let's say the square root of this positive value is some value k over 2a, or negative b minus some value, that's a b, over 2a. So we get two distinct values, right? Negative b plus something, negative b minus something over 2a. That's two distinct values. So this is what we want to do. That'll give us two distinct values. Okay, so we need to say that thing. So that's our b squared minus 4ac. So we want to say that must be bigger than 0 in order to have two distinct points of intersection. Okay, so b squared, our b value here is this. So b squared minus 4 times a is 1, right? There's a 1 there, times c. And this is our c, our constant. So 4ac must be bigger than 0. All right, now we need to solve for c. So that's the question, right? Find the set of values of c. Okay, so let's square this bracket. That's going to give us 4c squared minus 16c plus 16. And here, negative 4 times 4 is negative 16. Negative 4 times negative c is plus 4c, bigger than 0. That'll give us 4c squared. And then our c, so negative 16c plus 4c is negative 12c. And then 16 minus 16 here in the middle, that cancels out, that's 0. So, oops. Where's my eraser? Just get rid of that. Okay, so that's supposed to be bigger than 0. Simplify a bit more, we can divide everything by 4 to get c squared minus 3c bigger than 0. And then we can factor c minus 3 bigger than 0. Okay, now here, this next part is where people sometimes get something wrong. So what you cannot do, so don't do this. Don't say this is bigger than 0 or this is bigger than 0. And then you get c bigger than 3 or c bigger than 0. That is not correct. That would be correct. The correct would go if that was an equal sign. Then we could do that. But since it's not an equal sign, it's an inequality, what we want to do is we want to now say, okay, let's find our critical values. So our critical values are the following. Now that's when you treat this as an equal sign. So it's either c equals 0 or c minus 3 equals 0, which gives us c equals 3. So those are critical values for c. But now we need to use that. So let's sketch our graph quickly. So this is a parabola, right? So let's sketch that parabola. We know these are our c intercepts, right? Our solutions. So it's going to go through 0 and 3. So it looks something like that. And it doesn't matter where the turning points or any of that are. All we care about is that this value is 0 and this value here is 3. And now the question is, where is this parabola bigger than 0? So where is it above the c-axis, or the x-axis if you think about it in x and y terms? Well, that's this part here and this part there, right? So everything to the left of 0 or to the right of 3, which means that c must be to the left of 0, so smaller than 0, or c must be to the right of 3, or bigger than 3. And that is our solution. That's all the set of values for which there will be two distinct points of intersection. All right. And again, like always, if you use a different method to get to the answer, please let me know in the comments below, and we can have a look maybe at that. Maybe in some future video, I'll go through all the different possible solutions that some of the people came up with. All right, next up, find the term independent of x in the following expansions. Okay, so if some term is independent of x, that could be something like 3x to the power 0 is exactly the same as 3, right? So 3 doesn't have an x because it's the same as having x to the power 0, because x to the power 0 is just 1. And 3 times 1 is just 3. So we're looking for the term that has an x to the power 0 in it. Okay, so my favorite way to do this, and again there might be many different ways to do this, is to say that we know that the r plus 1th term, or term r plus 1, we can find by saying it's n choose r, and then, okay, so let's say we had a plus b to the power n. So from this, if we had that, then term r plus 1 would be n choose r, our first term, which is a, to the power r, and then our second term, in this case b, to the power n minus r. Okay, so that's the magic formula that we want to use here, or at least that I like to use. So in our case, we're going to say n choose r. Our n is 6, right? That's the n, so that's a 6. So n is 6. R we don't know yet. So 6 choose r. Our first term is 3x, so 3x to the power r. Our second term is 2 over x squared. 2 over x squared, and that's to the power n minus r, so 6 minus r in our case. Okay, now what we want to do is we want to split these things up so that we have x to the power something by itself in the end. Okay, so let's keep the 6 choose r, split this up into 3 to the power r, x to the power r. This one is going to be 2 to the power 6 minus r, and then x squared, we can take that to the top to become x to the power negative 2 to the power 6 minus r. Now let's collect our x's. So we have 6 choose r, 6 choose r, 3 to the power r, 2 to the power 6 minus r, and then we've got all our x's. So for the x's, now we need to put these two together. So we've got x to the power r, so it's going to be r plus, and here we've got this, so we multiply that together, that gives us negative 12 plus 2r. Negative 12 plus 2r. Right, so we'll keep all of this the same, and I'm just going to simplify this part here. So r plus 2r is 3r minus 12, right? If we add all that together, it just gives us 3r minus 12. That's going to be 3r minus 12. And what do we want? We want independent of x, so we want x to the power 0. And we have here x to the power 3r minus 12. 3r minus 12. So we're looking for this. So that means 0 must be equal to 3r minus 12. And then we can solve for r, which means 12 equals 3r, and then divided by 3, so 4 equals r. Now that we know that r is 4, we can plug this back in here. So 6 choose 4, 3 to the power r, and r is 4, 2 to the power 6 minus r, so 6 minus 4 is 2, and then our x is just x to the power, 3 times 4 is 12, 12 minus 12 is 0, so x to the power 0. So we mean we can just ignore that. And now we can just work this out. So 6 choose 4, I believe that's 15. Let me just make sure. Let's go to our friend Wolfram Alpha. So let's do 6 choose 4. Okay, that is 15, correct. Okay, so 6 choose 4 is 15, 3 to the power 4 is 81, and 2 squared is 4. Okay, so 4 times 15 is 60, 60 times 81 is 480, plus, 60 times 8 gives us 480, 4,860. 4,860. Let me just make sure. I don't want to lie to you here. Let's just take out the calculator. That's what it's there for. So times 81 times 4. 4,860. Correct. Okay, so that is our term independent of x. Okay. So now the question here was find the term independent of x in each of the following expansions. So this was our first one. Now we go to question B. And now we have two brackets. Okay, so now we have to take more things into account. Now luckily the first bracket here is what we've already done. So what we can do there is we can just copy this part here, right? This part here. Okay, because we've already simplified it to this, right? By multiplying everything out and getting the x's by itself. And then our other one is this one. So this one is pretty straightforward because there we don't actually need to do the r plus 1 thing. So let's first see x to the power 0. How can we get x to the power 0? Well, a couple of different options, right? Because we've got two things being multiplied. We've got this thing and this thing being multiplied. So this one is nice and easy because it's only got two options. It only has an x to the power 0 and an x to the power 3. Right, so that second one is either x to the power 0 or it's x to the power 3. So to get x to the power 0, what do we have to multiply with x to the power 0? Well, we need to multiply x to the power 0 with it, right? So if we multiply these two things, that's going to give us x to the power 0. X to the power 3, what do we need to multiply that with to get to x to the power 0? Well, x to the power negative 3. So if we multiply these two, it's going to give us also x to the power 0. So those are our two options. So basically for this first one, we need to find x to the power 0 for this one, which we've already done in this question, right? For x to the power 0, we've already found the coefficient here is going to be, let's do this. Let's say for, okay, so that's the first bracket, and then the second bracket we have, I'm just going to call it, write it down here, x1 minus x cubed. Okay, so the one option is when we do x to the power 0 here and x to the power 0 here. So if we find x to the power 0 for the first bracket, that's the one where we made this 0, found r equals 4, substituted the 4 in, and then we found that was 4,860. Okay, so that we just used from the previous section here. Substitute the 4 in because we found if the power has to be 0, then r equals 4, plug that in, we find 4,860. And then x to the power 0 in this one, so which term is x to the power 0 here? It's 1, right? So that's the coefficient there, it's 1. Okay, now we need to multiply those two together. So 4860 times 1 equals 4860. Okay, so there's the first part of our answer. Now we also need, when this whole thing, when this first term has x to the power negative 3. That's the second option here, right? So we need to find x to the power negative 3. So that means this has to be negative 3. So negative 3 equals 3r minus 12. So that gives us negative 3 plus 12 is 9 equals 3r. Divide by 3, so 3 equals r. So then we make the r a 3. So that's going to give us 6 choose 3. And then 3 to the power r is 3. 2 to the power 6 minus r, so 6 minus 3 is 3. And then x to the power negative 3, right? 3 times 3 is 9, minus 12 is negative 3. So our coefficient here is going to be this. So if we work that out, what is 6 choose 3? Is that like 21? Let's check. 6 choose 3, 20. Okay, so then we've got 20 times 3 to the power 3 is 27, and 2 to the power 3 is 8. So that's our coefficient there. So let's do that multiplication. The 20 times 27 times 8, 4,320. 4,320. And for this one, we need to find x to the power positive 3. So the x to the power 3 here, what's the coefficient for x to the power 3? It's negative 1, right? So that's going to be negative 1. So then all we do is we say this times negative 1 is negative 4,320. And now we just need to add these together, right? So it's either this times this, or it's this times this. So we add those together. So if we plus those two, what does that give us? 4,860 minus 4,320. That's 540. And there is our answer. 540. Oh, let me just make sure. So 4,860 minus 4,320, 540. Correct. All right. Next up, the first term of a geometric progression and the first term of an arithmetic progression are both equal to a. Okay, so before we get to that, let's just write down our formulas for this. So for an AP arithmetic progression, we have the nth term is the first term plus n minus 1 times the common difference. For a GP, we have the nth term is the first term times the common ratio n minus 1 times. Okay, so that's for an AP and a GP. So let's do this. So we know the first term of both is a. So let me just do this. I'm going to say here's an AP, and I'm going to do a GP here. Okay, so the first term is a and the first term is a. Okay, then the third term of the GP, so we have to go at least to the third term. So the second term would be a times r, right? Times r to the power of 2 minus 1. So a times r. The third term, we multiply r again, so that's ar squared. Fourth term, ar to the power 4. And the fifth term, ar to the power 5. We've got fifth term of the GP, sixth term of an AP. So we have to go with this one, we have to go to the sixth term. So the second term would be a plus d. The third term would be a plus 2d. Fourth term, a plus 3d. Fifth term, a plus 4d. And the fifth term, a plus 5d. Okay, so now we've written those out. You don't even have to write them out. This is just to show all the terms. But if they ask for like the 600th term, you obviously don't want to write the first 600. Then you just plug it in here. A plus 600 minus 1 times d, so a plus 599d would be the 600th term. All right. So the third term of the GP is equal to the second term of the AP. So this third term of the GP, oops, that's a square. Sorry, I messed up here. Let me just fix that. Just fix that, I skipped a number. So AR, then AR squared, then AR cubed, and then AR to the power 4. My apologies for that. Okay, so the third term of the GP, that's our third term, that's AR squared. So the third term of the GP is equal to the second term of the AP. So that's our second term, is this one, is equal to a plus d. Okay, now I'm just going to simplify it a little bit. I'm going to take the a across, so AR squared minus a equals d, and then factor out an a. So we've got r squared minus 1 equals d. And let's call that equation 1. Okay, now we've also told us the fifth term of the GP. So 1, 2, 3, 4, 5, the fifth term, AR to the power 4, equals the sixth term of the AP. So 1, 2, 3, 4, 5, 6. So the sixth term of the AP, a plus 5d. So let's do the same thing here. AR to the power 4 minus a equals 5d. So factor out an a, r to the power 4 minus 1, and then divided by 5 equals d. Okay, let's call that equation 2. Given that the terms are all positive and not all of them are equal, find the sum of the first 20 terms of the AP. Okay, so let's just add another formula here. So, not t, Sn, the sum of the first n terms of an AP is n over 2 2a plus n minus 1 times the common difference. And where this formula comes from, a very cool story, you can go read about it. Carl Friedrich Gauss, the Prince of Mathematics. He's the one that came up with the idea for this formula when he was very young still. So yeah, definitely go look that up. Very interesting. All right, so in terms of a, we need to find the sum of the first 20 terms. Okay, so let's see what happens if the problem here is there's 3 unknowns, right? A, R, and D. So let's see if we can somehow cancel out something to find a couple of things in terms of each other. So I'm going to say we're going to put this equal. We've got d as the subject of each formula, so we can put the other parts equal to each other. So we can say a r squared minus 1 equals a r to the power 4 minus 1 over 5, right? Because d equals d. Both of these things are equal to d, so they're equal to each other. And now the nice thing here is if we divide both sides by a, then the a's cancel, right? If we divide this left-hand side by a, what's left is r squared minus 1. Whoa. R squared minus 1. And on the right-hand side, it's r to the power 4 minus 1 over 5. All right, let's multiply both sides by 5 just to get rid of the fraction. So 5 times r squared minus 1 equals r to the power 4 minus 1. What can we see here? Difference between two squares. So we can do this one, but I'll just leave that one because it looks like that is going to cancel out if we just factorize this right-hand side. So factorizing the right-hand side, we get r squared plus 1 and r squared minus 1. And if we divide by r squared minus 1 on both sides, then we get 5 equals r squared plus 1. Again, subtract 1 from both sides, so we get 4 equals r squared. And then take the square root, which is plus or minus 2. But since all the terms must be positive, r cannot be negative. Right? Because if r is negative, every second term will be negative if we multiply by a negative. So r equals 2. Okay, now let's see if we can find d in terms of a or something. So I'm going to use this one. It looks the simplest. So we've got a r squared, but we know what r is. R squared minus 1 equals d. So a times 2 squared is 4, 4 minus 1 is 3 equals d. So 3a equals d. Okay, so now we have d in terms of a, and we've got a value for r. So we can write everything in terms of a. Okay, here's our formula. So we're going to say the sum of the first 20 terms is equal to 20 over 2 2a plus n minus 1, so 20 minus 1 times d. And we just found d is equal to 3a. d is equal to 3a. All right, let's simplify. 20 over 2 is 10. 2a plus 20 minus 1 is 19. 19 times 3 is 57, so plus 57d. 57a, sorry. 57a. And 2a plus 57a is 59a, times 10 is 590a. And there is our answer. Sum of the first 20 terms in terms of a. Okay, so again, I'm pretty sure there would be quicker ways to do this, but I'm just doing the first thing that comes to mind, and hopefully it's still a little bit instructive. Next question. So express this in that form. This looks kind of familiar. This is from completing the square. So we're going to say, let's go back to this color. So first, let's factor out a 2. And then what's left is x squared minus 4x plus 7. That's the first step in completing the square. We need to factor out the a, the thing in front of the x squared. So that gives us that. Now we want to rewrite our first two terms, and then we're going to add and subtract something. So we're going to add and subtract half of this value squared. So half of that value squared. And we're going to subtract it again so we don't change anything. Right, so we're adding something, taking it away again, so we're not changing the expression, so that's fine. And then we still need to add our plus 7. And the reason why we did that is that this part is now a perfect square. Let me actually just move this down a little bit. So 2 bracket, and now this part, which is just underlined here, this can factorize into x, this sign, and the value in the bracket, ignoring the sign. So 4 over 2 is 2 squared. All right, and now we just have to calculate this part. Okay, so calculating that part. So negative 4 over 2 is negative 2. Negative 2 squared is 4. Negative 4 plus 7 is 3. Okay, and there we are. 2x minus a squared plus b. Success. So let's just do this to show that's our final answer. Now next, functions f and g are defined by this. Okay, so the nice thing here, we can see this is the same equation we just had, and we rewrote it in this form. Okay, so what I'm going to do is I'm just going to bring this across here to show that is what this thing is written as. Okay, we've rewritten that in this form. Now describe fully a sequence of transformations that maps this graph onto this one, making clear which order the transformations are applied. So this is nice. This one we can easily see the transformations. So we want to, and because of BODMAS or PEMDAS, working with from the inside to the outside, that's quite a nice way to think about it. Okay, so we know if we've got x minus something in bracket, this has to do with the sideways movement of the graph. So we can say first shift 2 units to the right. Right, if it's a negative or minusing, it shifts to the right. If it's plus, it shifts to the left. Then we can say also it shifts 3 units up. So shift 3 units upwards. 3 units upwards. And then multiplying a function by some value stretches it vertically. So then stretch vertically, or we can say stretches in the y direction vertically by a scale factor, or with a scale factor of 2. Okay, so that's the one way to say it. And that's probably the most normal way, working from the inside brackets outwards. We could also combine steps 1 and 2, or these numbers 1 and 2, by just saying it's a transformation. Let's call that one. Transformation by, and now we just say what vector is the transformation? Well, it's 2 to the right and 3 up. Okay, transformation by this. And then secondly, we can say this again. Stretch in the vertical or the y direction with a scale factor of 2. All right. Next up. Okay, so we've got equation of the circle here, the equation of the straight line here. Okay, the circle with equation this and the straight line with equation that are shown in the diagram. The line intersects the circle at A and B, as we can see on the diagram, and the center of the circle is at C. Okay, find by calculation the coordinates of A and B. Okay, so A and B, what happens there? We see the two graphs intersect at A and B. So where do they intersect? Well, at the points where they intersect, they're equal to each other. So that's all we'll do. So we know already y equals 3x minus 20. So instead of y, we can put 3x minus 20. So we can say x plus 1 squared plus y, but y is 3x minus 20. So y minus 2 squared equals 85. Okay, and then we just solve for x to start with. So squaring this bracket gives us x squared plus 2x plus 1. This bracket, so that's going to be 3x minus 22. So 3x squared is 9x squared. 3 times negative 22 is negative 66, minus another 66 is negative 132x. And then 22 squared is 484. And I'm going to take the 85 across, so minus 85 equals 0. Let's collect like terms. X squared plus 9x squared is 10x squared. And then 2x minus 132x is minus 130x. And then 1 plus 484 is 485. Minus 85 is just 400. That's quite nice. Nice numbers equals 0. So now we can divide everything by 10, which makes it a lot nicer. So x squared minus 13x plus 40 equals 0. Solving quadratics, we can use either the quadratic formula, we can use factorizing, or we can use completing the square. This one seems like it's going to be nice to factorize, so I'm going to do that. It's going to be x and x. minus 5 and minus 8, because negative 5 times negative 8 is 40, and negative 5x minus 8x is negative 13x, so that works out. So this means that either this is 0 or that's 0. So either x minus 5 equals 0, which means x equals 5, or x minus 8 equals 0, which means x equals 8. Okay, then we have to find the y values. So now we can just plug that back into our equation. You can use either one of these equations to solve for y. I'm going to take the straight line, it looks simpler. Y equals 3x minus 20. 3x minus 20. So if we substitute the 5 in, we get y equals 3 times 5 minus 20, which gives us 15 minus 20 is negative 5. And the other point, if we substitute 8 in, so y equals 3 times 8 minus 20, that gives us 3 times 8 is 24, minus 20 is 4. So now we have 2 points. One point is 5, negative 5. The other point is 8, 4. So now we have to check which one is A and which one is B. Well, A, we can see here x and y are both positive in this quadrant. So that's going to be this one. That is A. Then this one must be B. Positive on the x side, negative on the y side. So that's right. It's positive on the x side and it's negative on the y side. Good. Points A and B are found. Next, find the equation of the circle which had its center at C. Okay, so same center, so that's quite nice. So this tells us that this will remain the same, right? Because that tells us what the center is, negative 1 and positive 2. So C's coordinates are negative 1, positive 2. Okay, so center with circle, circle with center C, and for which the line with this equation is now tangent to the circle. So now this line must be a tangent to the circle. So a couple of ways we can do this. I can see 2 ways to do this straight off the bat. And the one is, since this is a bigger circle, all we need to do is make this circle smaller. So we have to find just this distance must become smaller now. We have to find this distance. And in order to do that, we know that if it's a tangent, then this will be 90 degrees, right? Because a tangent and a radius make 90 degrees for this new circle that's going through there. So we can use that idea to know that for it to be 90 degrees here, that means that these 2 parts are equal. So that means this point is going to be the midpoint of A and B, and then we can just find this distance to be the radius. That's probably the shortest way to do it. So I'm going to do 2 ways. I'm going to do this one way. So let's first find the coordinates of this point. So that's the midpoint of A and B. Okay. So let's call that point M. Point M for the midpoint. Okay, and let's also just bring A and B down so we can use that. So there we go, that's A and B. So M is the midpoint of A and B. So M is going to be midpoint of the x values, so 5 plus 8 over 2, and the y value is going to be halfway between the y values, negative 5 plus 4 over 2. So let's just simplify that, and that's going to give us 13 over 2 and negative 1 over 2. All right, so now we need to find, let's also write down the coordinates for C. So C is the point negative 1 and 2. Because our equation was x plus 1 squared plus y minus 2 squared equals 85, which is, and 85 is then the r squared. So our midpoint of the circle, or the middle of the center of the circle, is that, negative 1 and positive 2. Okay, so now the radius of our new circle is going to have the distance MC, right? Let's write it like this. Let's say r, the radius, is going to be the distance between M and C. So r equals, now distance, that's just the Pythagorean formula. So difference between the x values, so 13 over 2 minus 1. So minus 1 becomes plus 1 squared. Difference between the y values is going to be negative a half minus 2 squared. So r r squared is then going to be just squaring this whole thing. So 13 over 2 plus 1. 1 is the same as 2 over 2, so that's going to be 15 over 2 squared plus negative a half minus 2 is negative 5 over 2 squared. So r squared equals, so that's going to be 225 over 4 plus 25 over 4. So r squared is going to be equal to 250 over 4, and then we just simplify that. So divided by 4 is at 62.5. Okay, 62.5. Or you can leave it as a fraction, which would be what, 135 over 2. 125 over 2, sorry. Or 125 over 2. That's also fine. Okay, and now the equation of the circle. So the center is still the same, so it's still going to be x plus 1 squared plus y minus 2 squared equals r squared. And we just found r to be 62.5 or 125 over 2. So that is our answer. Okay, but now I also said let's also try another method. Let's also say, again, where they intersect the points, so there'll only be one point of intersection now if it's a tangent, right? So now this equation and this equation will only intersect at one spot. The center is still the same, so this part remains the same. It's just this part we don't know because the radius will change of the circle. So that's going to be r squared. So we can say, let's do it in a different color here. So we can say, where will we do this? Let's just do something like this. Just cordon off some space. Okay. So I'm going to start over here on the left. So our equation, x plus 1 squared plus y minus 2 squared equals r squared. And the other equation, y equals 3x minus 20. So we're going to find where these two things are equal to each other, but only at one distinct place, one spot. So again, we can replace the y here with the 3x minus 20. So x plus 1 squared plus 3x minus 20 minus 2, so 3x minus 22 squared equals r squared. Okay, let's multiply everything out, and we've already basically done that, right? Where was that? Over here. Multiplied everything out, and that gave us this whole thing. Only difference is instead of minus 85, it's going to be minus r squared. So we're going to have 10x squared minus 130x. So 10x squared minus 130x, and then plus 485 minus r squared equals 0. Okay, so we have a parabola or a quadratic equation again. So now we can find the x value for which this is true. Okay, so, oh wait, what did I want to do here? Oh, we want to know where this only has one solution. So only one solution is where delta, which is b squared minus 4ac, we discussed that earlier, where that is equal to 0. Then there will be only one solution. So b squared minus 4 times a times c must be equal to 0. Okay, so let's square this. So 130 squared, that's 16,900, I believe. Yes. Okay, so 16,900. And then minus, okay, 40 times 485. So 410 and 485. So 19,400, but there's a minus, so minus 19,400. And then negative 40 times negative r squared is positive 40r squared equals 0. Okay, so 40r squared equals, and then we've got the 19,400 minus 16,900. So that gives us 40r squared equals, so what is that? Minus 16,900, 2,500. So r squared equals 2500 over 40, and then r equals, well, we don't need r, we just need r squared. So let's just simplify. 2500 over 40, oops, divided by 40, 62.5. We get the same answer. Fantastic. Okay, 62.5. So again, our formula, the center is still the same. So x plus 1 squared plus y minus 2 squared equals r squared, and r squared is 62.5. So that's quite nice. So these are the two methods that I thought of to start with. Like I said, there might be many other ways to also get to the same answer, but that is basically the idea. Oh, sorry, I should have done that over here at the bottom. But we see here, same thing. X plus 1 squared plus y minus 2 squared equals 62.5. X plus 1 squared minus or plus y minus 2 squared equals 62.5. Okay, and there will also be timestamps for each question in the description below. That'll be for all this past paper things. There's always timestamps for each question. So if you go download the question paper and you've got a specific question you want to have a look at, just go check in the timestamps where the question is discussed. Question 7. Okay, show that this equals this. Okay, so I'm just going to start with the left-hand side. I'm just going to work with the left-hand side. I always work with the left-hand side unless there's something drastically funny that happens. So here we've got two fractions. If we want to subtract or add two fractions, we need a common denominator. So our common denominator is going to be when we multiply those together. So cos theta minus 2 sine theta times, and then cos theta plus 2 sine theta. That's our common denominator. I'm sure the top's going to be pretty large here. Let's do a big line. So here on the left we had sine theta plus 2 cos theta. Though this fraction still needs to be multiplied with this, right? So this top part still needs to be multiplied with the cos theta plus 2 sine theta minus, and then we had sine theta minus 2 cosine theta. That has to be multiplied still with this part, cos theta minus 2 sine theta. Cos theta minus 2 sine theta. Alright, now let's multiply everything out. So at the top here, multiplying those two brackets, sine theta cos theta, and then plus 2 sine squared theta. Plus 2 sine squared theta. Then plus 2 cos squared theta. And then plus 4 cos theta sine theta. 4 sine theta cos theta. Cos theta sine theta cos theta, same thing. Minus, and then remember to put your brackets. I've seen too many people lose unnecessary marks for just minusing this first part and then forgetting the rest. Okay, sine times cos is sine theta cos theta. Then sine times sine, so minus 2 sine squared theta. Then this times this is minus 2 cos squared theta. And then minus times minus is plus 4 sine theta cos theta. Okay, so there's our numerator. Now in the denominator we usually don't want to multiply out, but in this case I think we do want to, because we want to get rid of all the sine things because there's only a cos in the answer. So I'm going to multiply out the bottom part as well. So cos squared times cos squared. Well, this is just the difference between two squares working in reverse, right? So cos times cos is going to be cos squared. And then cos theta times 2 sine theta, so that's 2 sine theta cos theta minus 2 sine theta cos theta, so that cancels out. And then we've got minus 4 sine squared theta. All right, making progress. So now at the top, sine theta cos theta plus 4 sine theta cos theta, so that gives us 5 sine theta cos theta. And here in the bracket, we've got sine cos plus 4 sine cos, so also 5 sine theta cos theta, but there's a minus. So 5 sine theta cos theta minus 5 sine theta cos theta just cancels out. So let me do this. Let's just show what we can cancel out. So that cancels out with that. All right. Next we've got 2 sine squared theta minus 2, so plus 2 sine squared theta. That's going to be 4 sine squared theta. Okay, so 4 sine squared theta. Then the cos squared. So 2 cos squared theta minus, so plus 2 cos squared theta. So it's going to be plus 4. Oops. So plus 4 cos squared theta. And that's all that's left at the top. What a bargain. At the bottom, here, we want to change the sine squared into a cos squared. So that's going to be cos squared theta minus 4 times, and sine squared is the same as 1 minus cos squared. Okay, at the top here, we can factor out a 4. We're left with sine squared plus cos squared. So sine squared theta plus cos squared theta. At the bottom, we've got cos squared theta minus 4 plus 4 cos squared theta. Okay, so at the top we've got 4. Sine squared plus cos squared is just 1. So we've just got 4 times 1. Don't need to write the 1, but just to show what we did. And then we've got cos squared plus 4 cos squared is 5 cos squared minus 4. Okay, so there we have our answer, right? We can just ignore the times 1 part. I believe that is what they want. 4 over 5 cos squared minus 4. 4 over 5 cos squared minus 4. Perfect. Perfect. All right. Next up, what I also like about these exams, they give you a whole page to do some workings, because I mean often we make a mistake somewhere and we have to do all of this again. So it's nice that you have lots of space to work with. Hence. Okay, hence means we use the previous answer. So since we know this is equal to this, we can just use that. Okay, so solve this equation. So now we know that that whole thing can be simplified to this. So that's the same as this whole thing, right? We just proved that that's the same as what we have here, equals 5. Okay, so many ways we can simplify this. I'm going to get rid of the fraction first, so multiply both sides by this fraction here. So let's multiply 5 times 5 cos squared is 25 cos squared, and then 5 times negative 4 is negative 20. So now we want cos squared by itself, so take the 20 over, it becomes 24, and then divide by 25 equals cos squared theta. And then we need to find the square root. So we've got plus minus square root of 24 over 25. I'm going to simplify that a little bit. Square root of 24 can simplify to 2 square root 3, and the square root of 25 is 5. Okay, so that equals cos theta. And now to find theta, our reference angle is going to be arc cos, or shift cos in calculator language, of 2 root 3 over 5. So what will that give us? And now this is in degrees, so let's find our answer in degrees. So we've got arc cos of, now how do I type this? 2 times square root of 3 divided by 5. That's right. 46. I hope that's right. Did I put brackets in the right places? 2 square root 3. Oh wait, I need to put another bracket there. Oops. Or remove one with that. Okay, 46.14. So our final answer needs to be 2 decimal places. I mean 1 decimal place for angles in degrees. So for this one, let's use more than 1 decimal place until we get to our final answer. So what I like to do is just write the whole calculator display. So that's our reference angle. And now we check. So was this a positive or negative value? Well, both. Right, so cos is positive or negative in all 4 quadrants. So we need all 4 quadrants. So in the first quadrant, and we also need to check here. First quadrant, that is fine between 0 and 180, right? So in the first quadrant, we just have our normal acute angle. So that's going to be 46.1 degrees in the first quadrant. In the second quadrant, yes, that's between 0 and 80. Second quadrant, remember how this works. So we've got here 180, here we've got 360. So 180 minus is that quadrant, 180 plus is this quadrant, 360 minus is this quadrant. So the second quadrant, it's 180 minus the acute angle. So here we'll have 180 minus the 46.1 degrees, which will give us 180 minus 46, it's at 133.9, I think. Let's just make sure. 180 minus 46.1, 133.9 degrees. Okay, 133.9 degrees. So there is our answers. It's either going to be that or that. Those are the only answers in the first two quadrants, in this quadrant and that quadrant, right? All right. Next up, we've got a circle here. They've given us an equation. Okay, the diagram shows a circle with this equation. Chord AB of the circle intersects the positive y-axis at A and is parallel to the x-axis. Okay, so it's parallel to the x-axis. Okay, good. So we know the y value doesn't change along here. Find by calculation the coordinates of A and B. Okay, so let's first find the coordinates of A, because we know the x value at A, right? We know the x value is 0 because it's on the y-axis. Cuts the y-axis at A. So we just make x 0 for that. So 0 minus 2. Let's actually do this. Let's say we're busy finding point A. So we're going to say 0 minus 2 squared plus y squared equals 8. Okay, so negative 2 squared is 4. So 8 minus 4 is 4. And then y equals plus or minus 2. But in our case, we know A, we can see it's a positive y value. So y equals 2. So the coordinates of A are 0, 2. Okay, now the coordinates of B. So now we know B is the same y value as A. So know the y value for B. So in order to find B, we make the y value 2. So we've got x minus 2 squared plus y squared equals 8. Okay, squaring this bracket gives us x squared minus 4x plus 4 plus 2 squared, which is also 4, equals 8. So that gives us x squared minus 4x, then 4 plus 4 is 8, minus 8 is 0. So factor out an x minus 4. So either x equals 0 or x equals 4. But this one is already used in A, so B must be x equals 4. So the coordinates of B is going to be 4 and 2. So there are the coordinates of A and B. Okay, now find the volume of revolution when the shaded segment bounded by the circle and the chord AB is rotated through 360 about the x-axis. Okay, so this little shaded part is now rotated about the x-axis. So it forms a solid. So let's imagine we're looking at it from this side. What would that look like? Looking at it from this side, so I'm going to imagine we're going to rotate it so that after we formed the solid, now we're looking at it from the top. Right, so basically, okay, let me first do this. Just to get us a better idea. Okay, so this part is also going to be shaded. That's a solid that forms. So if you look at it from the right hand side here, we'll see some sort of a cylinder in the middle, right? This part here is going to be an empty cylinder with this at the side. So it's going to look something like that from the side. Right, that's the open part in the middle, and then it's going to be this thick around. Right, that's the shaded part. So we need the volume of that part. But remember, it's not evenly thick all the way around. It's a bit curved. It's not like this, right? That it's around. Okay. But that's the basic idea of what we want. So finding the volume. So if we look at it from this side also, we can see it makes a circle, right? A volume of revolution. So we'll have a radius, we'll have another radius. Let's call that big R. And that's basically the idea. So these radiuses will be the y values for this graph, right? So that'll be the radius if we look at it from this side. So that's going to be our small r idea. This is going to be our big R, basically. Okay, but let's just get to what we want to do. So basically, if we want to find volume, is when we integrate the area. That's the basic secret sauce we'll use here. Okay, so we want to find basically the volume of this whole thing minus the volume of this empty cylinder. A couple of ways we can do that. I'm going to use integration for both. I'm going to say we're going to integrate the outside part, the big circle part. So let's say big circle part. And the area of a circle is pi radius squared, right? So we're going to integrate that minus integrate the inside circle. So that's the idea. So that means we're going to integrate, and the outside part here, that's the equation of the circle, right? And x value of a is 0, the x value of b is 4. So we're going to integrate from 0 to 4 this outside circle, which is the equation of the circle. And what was that? That was x minus 2 squared plus y squared. Let me just write that down. So the circle has this equation, x minus 2 squared plus y squared equals 8. Okay, and we want to get y by itself because we said the radius here is r, right? Is the y value, it's the up value. So we're going to get y squared by itself. So y squared equals 8 minus x minus 2 squared. Okay, so we're going to integrate pi times the radius squared, and our radius is y, right? And our y in this case is 8 minus x minus 2 squared. So it's pi y squared with respect to x minus, and we said we're going to do this from 0 to 4. Minus, and this one we're also going to integrate from 0 to 4 this equation. And what is this equation? That equation is just y equals 2, right? That's the equation of that line. So y equals 2. So our y, or pi, times y squared. And our y is just 2 in that case. Alright. So I hope I explained it alright-ish so that you guys can at least have an idea of why we're doing this. So let's do the integration part. Well, the most important part to understand is the volume is when you integrate the area. That's basically what you want to understand here. Okay. So let's integrate. So integrating, we can also, let me just actually do this. If we integrate, we can take a constant out and do that. Right, so I'm going to do this with both of them. I'm going to say minus pi times the integral. So the integral of the product is the same as the product of the integrals with a constant part, Okay, so that's going to equal pi times. Okay, now integrating. Should we use the chain rule here, or should we multiply out? I suppose it doesn't really matter, right? Let's multiply this one out in this case. So before we integrate, let's first multiply out. So we're going to say that still pi integrate from 0 to 4, and now we're going to multiply out. So 8 minus, we multiply this bracket out, we get x squared minus 4x, so the minus is going to make that a plus 4x, and then plus 4, so that's going to make it a minus 4, and then 8 minus 4 is just going to be 4, right? So I'm just going to take that away. So we want to integrate that. And then this one, nothing to happen here. We're just integrating 4 with respect to x. Okay, now let's actually do the integration. So pi times, so negative x squared becomes negative x, add 1 to the exponent, divide by the new exponent. Plus, for x, add 1 to the exponent, divide by the new exponent. plus 4, add 1 to the exponent, divide by the new exponent. So I'm not going to write divide by 1. I want to do that from 0 to 4 minus, then integrating 4 just becomes 4x. And again from 0 to 4. Okay, so let's put the values in. Okay, so first we're going to substitute in the 4. So negative 4 cubed is 64, so that's negative 64 over 3. Plus 4 squared is 16 times 4 is 64. 64 over 2 is 32. And then 4 times 4 is 16. Minus, and then we're going to substitute in the 0. So 0 divided by something is 0, plus 0 plus 0. So that's just going to be 0. Minus pi over here. Let's first substitute in the 4. 4 times 4 is 16. Minus, and substitute in 0. 4 times 0 is 0. So that gives us pi times. So here, let's put everything over 3. So 32 plus 16 is 48. 48 times 3 is 144. 144 minus 64 is 80. So 80 over 3. Minus, and then we've got pi times 16. All right, so let's simplify that. So 16, it's the same as 48 over 3. 80 minus 48 is 32. So we've got 32 over 3 pi. Okay, but I mean from here you can just type all of this in your calculator straight up. Obviously don't need to simplify without a calculator. And there you go, 32 pi over 3 is our answer for the volume of the revolution there. So what we did, we found the volume of, I'm just going to do this to show something here. So we first found the volume of this whole thing. Right, we found the volume of that whole thing after it's been revolved around the x-axis. And then we subtracted from that the volume of this cylinder. So we subtracted from that the volume of this cylinder. So all that's left was the outside part. So that's basically what we did to find the shaded volume here. All right. Question 9, how many pages do we still have? Oh, we still have quite a bit to go. Okay. So we've got two functions. Okay, the functions f, g, and h are defined as follows. Solve the equation f of x equals 0, giving your solution in this form. Okay, so f of x equals 0. So 0 equals x minus 4x to the power half plus 1. Okay, so we see this is a quadratic equation because this exponent is double that exponent. So we can say then the smaller exponent 1, that one, equals, and I'm just going to use the quadratic formula here. So negative b, negative 4, plus or minus square root of b squared, so negative 4 squared is 16, minus 4 times 1 times 1, so just minus 4, over 2a, 2 times 1. So x to the power half equals, simplify this a bit, 4 plus or minus square root of 12 over 2. And again, your calculator will simplify that for you, I believe. I'm just going to do, so square root 12 we can also write as 2 square root 3 over 2. So x to the power half equals, so we can factor out a 2 and then cancel it out. So it's just going to be 2 plus or minus square root 3. Okay, so this is x to the power half, but we need to find x, so we can square both sides. So square both sides. So that gives us x equals, so 4 plus, squaring both sides, so it gives us 4, and then plus or minus, because we can either have plus 4 root 3, so plus or minus 4 root 3, and then plus 3. Okay, so that gives us x equals 4 plus 3 is 7. So 7 plus or minus 4 root 3. And there we go. that is our solution. So basically the A would be 7 and the B would be plus or minus 4. Alright, and then the C would be 3, obviously. Now given that f of x is identical to gh of x, okay, so f of x, I can write that down so long. So f of x was x to the power, did I write? Yeah, x minus 4x. So x minus 4x to the power half plus 1. And that is identical to gh of x. Okay, so gh of x. So that's when we put h into g. So g is just mx squared plus 1. So g is m x squared plus 1. And now here we're going to put h of x. And the h of x is x to the power half minus 2. Okay, x to the power half minus 2. Okay, so let's simplify that. So this will give us x minus 4x to the power half plus 4 plus 1. So multiplying that out gives us mx minus 4mx to the power half plus 4m plus 1. Okay, so these two are identical. So that means the coefficients of the same variables must be the same. So for x to the power 1, on the left hand side we've got a 1 as a coefficient, right? So that must be equal to the coefficient of x on the right hand side, which is m. Okay, so they've already solved for m. Then for x to the power half, on the left hand side we've got negative 4. So on the right hand side, negative 4m. Okay, so that's just going to yield the same answer. Divide both sides by negative 4 and we get 1 equals m. So we already have that. Doesn't help us much, but at least it's nice to see that we're right. If this wasn't the same, we'd have a contradiction, which would be a problem. And then for our constants, on the left hand side we've got 1. On the right hand side we've got 4m plus 1. 4m plus 1. So this implies that 1 is equal to 4 times m, but m is 1 plus... Wait, what? Where's... I missed this. Oh, plus n. My bad, that's an n. That's an n, so that's an n. So this is an n, and this is an n. Okay, then 1 minus 4 is negative 3 equals n. And there we go. We have m and n solved. So m is 1, n is negative 3. Next question. So here, diagram shows a circle with center A of radius 5. Just let me put in the 5 here so long. And a circle with center B of radius 8. Okay, so we know this part is 8 as well. So radius. The circles touch at the point C, so that ACB is a straight line. Okay, that's a straight line here. The tangent at the point D on the smaller circle intersects the larger circle at E and passes through B. Okay, fantastic. Now find the perimeter of the shaded region. Okay, so we need to find this perimeter. So that, and that all together. So basically we have to add all of those. So let's first, I think to me the easiest looks like to find this distance, or the quickest. So we can see it's a right angled triangle. So we can use Pythagoras to find the distance DE by first finding DB, right? So we're going to say DB equals, or let's, if we want to make it nice and formal and do everything in one step, we can say DE plus 8 squared is equal to, well not equal to, plus the other side squared, DA squared, which is 5, equals to AB squared, which is 13 squared. Okay, so this gives us then DE squared plus 16DE plus 64 plus 25 and then minus 169 equals 0. Okay, So this is actually a longer way to do it by writing everything in one go. But that's fine. Let me just do the shorter way. So we're just going to say that db squared. So we're just going to say db squared plus 5 squared equals 13 squared. Okay, so db squared equals 169 minus 25, 144. So db equals the square root of 144, which is 12 or minus 12. But we're just going to use 12 because it's a distance. So if this whole thing is 12, then this must be 4, right? Because 4 plus 8 is 12. Okay, so that means that dE equals 4. Let me just write that down. dE equals 4. And you're welcome to work the rest of that out to see that you get the same answer. So for if dE equals 4. So basically what we want to do is we want to show the distance, the perimeter. We're going to call it P for perimeter. Perimeter is equal to dE plus EC. Let's put it like that. Curve EC plus the curve CD. Right? And DE is a straight line. So we want to find that. Okay, so DE we already have. So DE we found already to be 4 now. Now we need this curve EC. So that is just the arc length EC. So we need this angle in order to find this, right? So how do we find this angle? Well, we can use, let's say, cosine. So cos of B equals 12 over 13. Okay, so let me do this to find EC, to find the arc length EC or the curve EC. We're going to say the cosine of angle B is equal to dB over AB. So 12 over 13. 12 over 13. Which means that angle B is the arc cos, or arc cosine of 12 over 13. Okay, so that's angle B. Now, to find the arc length, we're going to say this angle over, and I mean, if you do radians or degrees, doesn't matter. I'm just going to do degrees, I think, because I don't know how to make this thing into radians. I'm not really sure. But there it is. It gives you both. Okay, so that's actually quite nice. But I'm just going to use degrees. I'm not sure about the radians thing on my calculator. Times 2 pi r, because that's the circumference. And our radius is 8 in this case. Okay. So what does that give us? So let's see, 2 and 8 becomes 16, all that. I'm just going to simplify some of this a little bit. So the 2 can cancel out with this to make that 180. And then 180 and 8, both of them can divide by 2. That gives us 90 and 4. Both of them can still divide by 2. So that gives us 45 and 2. Okay, so we've got 2 pi over 5 times the arc cosine of 12 over 13. So apologies for being this messy. I'm just trying to find things that work in my calculator here. I don't have the nicest calculator on this thing. So 2 pi over 5, well, let's first do the multiplication. So times arc cos of 12 over 13. So that answer divided by 5. So 28.42. Let's just use this whole thing for now. We only need one decimal place rounded off for angles in degrees, but let me just do this. Okay, so that is the arc length, that's CE. Okay. Then, does that make sense? That does not make sense. What did I do here? Okay, let's actually, let's do radians and then let me just use Wolfram alpha. Okay, so our cos over, so the formula would be over 2 pi times 2 pi r, right? But the 2 pi's cancel out, so that's quite nice. That's why radians are better than degrees, because it makes life a lot easier. And our radius in this case is 8. Okay, so we've got 8 times this. So 8 times arc cos of 12 over 13. Okay, for now I'm just going to write that. So plus 8 arc cos of 12 over 13. And then we're going to do CD. So for this one, for this sector, we need to find this angle. So I'm again going to use cos. So cos of A equals 5 over 13. Okay, so for CD. For CD, we're going to do cos of A equals 5 over 13. So A equals arc cos of 5 over 13. So then, to find the arc length, we're going to say arc cos of 5 over 13 over 2 pi radians times 2 pi times the radius. Not 4, 5. The radius is 5 for that circle. And again, the 2 pi's cancel out, so that's just 5 times the arc cos of 5 over 13. Okay, so I'm just going to put that in here. 5 times the arc cos of 5 over 13. Okay, so now that perimeter, I'm going to use Wolfram alpha. Hopefully this is nice. 4 plus 8 times arc cos how do we do arc cos here? Arc cos of 12 over 13 plus, and then 5 times arc cos of 5 over 13. Okay, so that's 13.038. Okay, 13.038, etc. And we have to round off to 3 significant figures, so 13.0. That's it. And remember to put our units. They told us it's centimeters, so we have to put centimeters. Okay. Find the area of the shaded region. Okay, so to find the area, let me erase this here first. To find the area of the shaded region, we can find the area of the whole triangle minus this sector area minus that sector area. And then what's left is going to be this part. So we're going to say area of triangle minus area of one sector minus the area of the other sector. Okay, so the area of the triangle, pretty straightforward. Half times base times perpendicular height. So half times 5 times 12. Okay, so half times 5 times 12. And then the area of sector 1, let's call this sector. So it's going to be this angle, so arc cos of 5 over 12, 5 over 13 times pi radius squared, right? So for this sector here, sector ADC, we're going to say that is our angle, so arc cos of 5 over 13 over 2 pi times pi radius squared. Okay, so the pi's will cancel out. So it's just going to be radius squared, so 5 squared. So 25 arc cos. So it's going to be 25 arc cos of 5 over 13 over, what is at the bottom? 2. Okay, 25 arc cos something over 2 minus the area of the other sector. So this angle was arc cos of 12 over 13. So this area is going to be times r squared, so it's times 64 divided by 2, so that's just going to be 32 arc cos of 12 over 13. 32 arc cos of 12 over 13. Okay, so area of the triangle minus the area of the one sector minus the area of the other sector. So again, let's do that. So half times 5 times 12 is going to be 30. I'm just going to put 30 for that. Minus, and then we're going to do, what was it, 25 times arc cos of 5 over 13 divided by 2 minus, and then the next one we had 32 times the arc cos of 12 over 13. And that's 2.666. Okay, so that gives us 2.666. So that's just two three significant figures. That's 2.67. And that's going to be centimeters squared. Remember your units. All right. Okay, we're getting towards the end there. Let me just make sure there's not another question there. Okay. So a curve has this equation where k is a constant. Find in terms of k the values of x at which there is a stationary point. So a stationary point is a turning point, right? That's where the gradient is 0. And how do we find the gradient? We differentiate. So let's differentiate this. So differentiate chain rule. So negative 1 times k is going to be negative k, 3x minus k, subtract 1 from the exponent, multiply by the derivative of the inside of the bracket. So if we differentiate this inside part, we'll get 3. Okay. So, and then also we have to differentiate that. So differentiating 3x, we get 3. Okay, so now we have to set that equal to 0, because where the gradient is 0, that's where we have a stationary point. So 0 equals negative k, I'm going to do negative 3k, 3x minus k to the power negative 2 plus 3. Okay, so take the positive 3 over, we get negative 3 equals negative 3k, 3x minus k squared. Divide by negative 3, so we get 1 equals k, let me do it like this, k over, if we can take this to the bottom to have that negative exponent at the bottom, 3x minus k squared. Okay, so now what we want to do, we want to find in terms of k the values of x. So we want to solve for x. Okay, so let's multiply both sides by this. So that's going to give us 3x minus k squared equals k. Multiply out, that's going to give us 9x squared minus 6kx plus k squared. And I'm going to bring the k over, so minus k equals 0. So then we can solve for x. So x equals negative b plus or minus, b is 6k. So negative b plus or minus square root of b squared minus 4 times a times c all over 2a. All right. So let's simplify that a little bit. So that's 6k plus or minus, and then square root. So here, this part's become negative 36k squared. So 36k squared minus 36k squared is nothing. So then all we have left is that times that. So negative 36 times negative k is 36k. And at the bottom we've got 18. So simplify even further. So we've got 6k plus or minus. Now 36 has a square root of 6, so we can say that's the same as 6 times the square root of k over 18. Now we can go even a bit further. X equals, let's factor out of 6. So 6k plus or minus square root of k over 18. And lastly, we can do that, which leaves us with k plus or minus the square root of k over 3. And there is our answer for x in terms of k, where it has a stationary point. Okay, next up, The function f has a stationary point at the value at x equals a, and is defined by this. Okay, so that's quite nice. So now we see what k is, right? So k is 4, because that was just k and k, if I'm not mistaken. Right, k and k, and that's the same thing. Yep, so k is just replaced with 4. So it's only for x greater than 3 over 2, so that's probably going to come in handy later. Find the value of a. Okay, so we already found that the stationary point is when x equals k plus or minus the square root of k over 3. Okay, so that is where it has a stationary point. But now we know that k is 4, so we can say x equals 4 plus or minus square root of 4 over 3. So x equals 4 plus or minus 2 over 3. So x equals 4 plus 2 is 6. 6 divided by 3 is 2. Or we've got x equals 4 minus 2 is 2 over 3. But like we said, x is only defined, or this function is only defined for x bigger or equal to 1.5, so that's bigger than this. So that one doesn't count, and this is then our answer. This is the value of a. Okay, so we actually just want to say that a equals 2. All right? And determine the nature of the stationary point. Okay, so we know there's a stationary point at x equals 2, but is it a maximum or a minimum? So for instance, a graph could look like this, right? So that would be a maximum stationary point, this would be a minimum stationary point. And how do we do that? Well, we do that by using the second derivative, because the second derivative tells us if the gradient is increasing or decreasing. So if the gradient is decreasing like this, right, so this gradient is like 100, 50, 1, 0, negative 1. So this gradient is decreasing all the time. We can see if the gradient is decreasing all the time, we'll have a maximum stationary point. So if your second derivative is negative at that point, we've got a maximum point. And if the second derivative is positive, we've got a minimum point. So let's find the second derivative. First derivative was, what did we have for that? First derivative was this, negative. Okay, we know what k is. So it's this, right? So let me just rewrite this. So our first derivative is negative 3 times 4, 3x minus k, which is 4, to the power negative 2 plus 3. Okay, so that's just negative 12, 3x minus 4, to the power negative 2 plus 3. Okay, so that's our first derivative. Let's just copy that down. So there's our first derivative. So now we need to find the second derivative, so we need to differentiate that again. So second derivative, so negative 2 times negative 12 is 24. 3x minus 4 to the power negative 3 times derivative of the inside, which is 3, and then differentiating 3, we get 0. Okay, so let's simplify. That gives us 72. 3x minus 4 to the power negative 3. Okay, now we found that stationary point is when x equals 2. So if we substitute that value in here, 72, 3 times 2 minus 4 to the power negative 3. So that gives us 72 over 3 times 2 is 6 minus 4 is 2. 2 cubed is 8. So that gives us 9. And now 9 is bigger than 0, which means we have a minimum stationary point. Right? If this value is positive, we've got a minimum stationary point, because that positive means the gradient is slightly increasing all the time, or is increasing at the point where this is happening. Okay, the function g is defined by this. Okay, so that looks pretty similar again, but not exactly the same. Now the only thing is the k is now a 1, right, or a negative 1 rather. Okay, determine making your reasoning clear. whether g is an increasing function, a decreasing function, or neither. Okay, so an increasing function means the gradient is always positive, right? Or it's never negative. So let's see what we can do. So we can use a shortcut and do the k thing again, but let's start this one from scratch. So let's find the derivative by saying -1 times -1 is 1, and then 3x plus 1 to the power -2, multiply by the derivative of the inside, which gives us that. Let's simplify that to 3 over 3x plus 1 squared. Oh, plus 3. Sorry, I forgot about this little part here. So plus 3. Okay, so that's our derivative. Now, what can we see here? Well, we can see 3x plus 1 squared is always going to be positive, right? Because x has to be bigger than 0, so if you put anything bigger than 0 in here, and anything squared has to be positive then, right? So if that's positive, then a positive, let me do this. So that implies that some positive value divided by a positive value will be positive. And that implies that a value that's positive plus another positive value will also be positive. So the gradient is always positive, which means we have an increasing function. Increasing function. Oh, is that it? That was the last question. Okay, guys, thanks for watching. Again, if you did something in any different ways, or if you want to know if there is a different way that you thought of that might be right, might be wrong, maybe you got a different answer, maybe you got the same answer using a different thing, please let me know and we can discuss that. And also, if you've got, I'm going to be doing a lot of these AS and A-level past exam papers. I see there's lots of them on the link that I'll give to you. So I'm going to try and do the last 10 or 15 years of past papers, and if you've got a different syllabus that you'd also like to see, and let me know and I can see if I can find some past papers and work through those as well. Alright, so that is it for this video. AS levels, AS A levels, Pure Maths 1, February, March 2022.